Okay, hi everybody. So looking at this iterated integral, we see we first are integrating u, and then integrate t. And it turns out that this will be a bad way to do it. And so if we switch the order to first do dt and then du, we'll be able to do it much more easily. Okay? In fact, it's sort of impossible to do this one, in a sense. Okay. So let's first, so I'll say in words. First step is to draw the region. The region of integration in R2. Well, we have a u variable and a t variable. So we could draw the plane in two ways. We could draw, let's see, like this, where t is here and u is here. Or like, nobody can stop us from drawing u here and t there. And either, you don't have to do both, but let's try to do one of them. Okay, so if t goes from 0 to 1/4, then t is here from t equals 0 to t equals 1/4, I guess. Or here t is 0 and to t is, I don't know, let's put 1/4 right there, okay? And then u goes from u equals square root of t to u equals 1/2. Okay, so if 1/4 is there, then I guess 1/2 is like here. And over on this u plane, here's 1/4, here's 1/2. U equals 1/2. U equals 1/2. Okay, and then what about this? U equals square root of t. This is also, could be written t equals u squared. Okay, so if u is the square root of t, then I guess, what's the square root of 1/4? So the square root of 1/4 is 1/2. 1/2 times 1/2 is 1/4. Okay, so this point is on the thing, and over here, that point is there. Okay, and yeah, so what does it look like? I guess it looks like either this or this. Okay, and then if t goes from 0 to 1/4 and u goes from the curve to 1/2, then I guess we're sort of in this region. The curve up to 1/2 is this region. Okay. So now, if we are first integrating u, what does this look like? It means that we fix t. So that means fix t. Okay, and so if I fix some t, then it's going to slice, yeah, and that makes sense. It goes, the bottom is the curve, u equals root t. The top is u equals 1/2, which is over here. Over here, if I fix t, then my left to right, the left is the curve, yep, and the right is the u equals 1/2 line. Okay, so both of these pictures are for this order, du dt. Okay. I'll even write that in words. Both pictures show fixing t and integrating u first. But problem, and I'll put this in words, problem, I don't know the antiderivative of e to the u over u. Well, of the function that is, of the variable u, sending it to e to the u divided by u. Let's call that little g. And I don't know capital G. What is G, capital G? I have no idea. And in fact, if you ask a computer to find capital G, what it will do is this. It will make up, so here's my first call to integrate. It'll make up this symbol, EI, called exponential integral. I think that's why they call it that. And it just says, well, this is saying g of b minus g of a. This is the fundamental theorem of calculus. G of u equals 1/2 minus g of u equals square root of t. Because remember, our integral went from square root of t up to 1/2. So this was g of 1/2 minus g of square root of t. And it just says that, but it has, it made up a new symbol because I didn't know the answer. Okay, so let's instead, solution, integrate the other way first. Okay, I'll put it in the same drawing. So if I fix, so now I'm fixing u, and this picture, it would be like that, fix u. Well, then I integrate too. So fix u, oh, this should be in red for fix u, and integrate over t first. And that will give a new formulas. The first formula will be t equals, now I have to look at my picture because I can't just say t equals 0 to 1/4. I need to take into account the endpoints of this pink. And so my t goes from 0 to the curve. My t goes from 0 to the curve. From 0 to the curve. Pause until you understand why I did that. T equals u squared. And now my function, which I'll call little g, sends t to e to the u over u. It just completely ignores t and spits out this. It is a constant function. U is fixed. It's a constant function. And so, capital G of t is a very easy function. It's just e to the u over u times t. Okay, great. Then the fundamental theorem of calculus says that I plug in at the endpoints. And that means I get e to the u over u. I replace a t with a u squared. And I replace t with a 0. And so my answer is the function e to the u times u. That's it. Okay. Next, integrate u over the u dimension. Okay, let's look at our picture again. U then, if we project onto the u dimension, project to u, in this picture, the u was this left-right, so then I go, here I am. And I should start at 0 and end at u equals 1/2. Right? So that's what I should do, u equals 0 to u equals 1/2. Right? Because I've already integrated away. The t dimension has disappeared. And so all this stuff gets projected onto just the u direction, which now has just endpoints, which are numbers, 0 and 1/2. So I have to, in a formula, I go from u equals 0 to u equals 1/2 of what function? Well, u goes to e to the u times u. And this is the function I'll call little h. And now, big H of u equals what? So the most important method is guess and check. This is more important than any other method, except perhaps the method of use a computer. Both of these are your most important methods. By the way, a lot of people would disagree with me. But anyway, so this is what we're going to do. We know that e to the u, the integral is e to the u. So why don't we just guess? Let's say that is h of u equal to just the same thing? Is that it? Well, okay, so partial u of e to the u times u is, well, the, f prime g plus f g prime. This is the product rule. And this is just in my head. I'm just thinking about this, so why don't I just do a thought bubble. And so I'll do the derivative here times the second plus the first times the derivative of the second times the derivative of the second. Oops. First times the derivative of the second is 1. Okay, so this is e to the u times u plus e to the u. Oh darn, we wanted just e to the u times u. But we got e to the u times u and some additional thing we don't want this. So I'm going to put in words don't want. Oh, but we know something whose derivative is that, namely e to the u. Okay, so instead of our guess e to the u over u, guess again. But now our second guess is informed by our first guess, and check. The check informs our second guess. Let's say that is e to the u, or is capital H, e to the u times u plus, or how about minus e to the u? Okay, let's check. Partial u gives, well, we already did this one. We get this. Plus e to the u. And then I have to differentiate this. Well, I just get the derivative of the exponential is the exponential again. And these cancel. And the answer is e to the u. And so I have found, we found capital H. We found H. Smiley face. Okay. So now we can use the fundamental theorem and just plug in at the endpoints and subtract. So this means that our integral is equals capital H of 1/2 minus capital H of 0. So capital H is here. So I do e to the 1/2 times 1/2 minus e to the 1/2. Okay, that's my h, that's my capital H. And then minus h of 0, I have to do e to the 0 times 0. Well, that's going to be 0. Minus e to the 0. Well, that's going to be 1. So now I get 1/2 of e to the h and a minus 1 of e, or sorry, 1/2 of e to the half minus 1 of e to the half. That's minus, just, 1/2 minus 1 is minus 1/2. So I get minus 1/2 of that thing. And then minus 1 is plus 1. That's my answer. And this is a number. This is a number. There's no more u's, there's no more t's. And that's it. That's the answer. Okay. So you see that it is beneficial to be able to slice in both ways. And so we had to change this and change this and get a completely different iterated integral, namely this one, where we first integrate t, and that was easy, and then we integrate u, and we were able to find our capital function that is the antiderivative in this case. Okay, great. That is all. All right, let's look at my other solution. Yeah, okay, so Here's my first one, here's my second one, and the picture here looks a little different. I drew a different picture, but it's the same picture. It's just I guess I went out farther, and it's the same region. Here I sliced vertically, here I sliced horizontally. So this was the switching order, slicing the other way first, fixing T, and slicing in U. Or no, fixing U and slicing T. Well, whatever I did, this is this is what it looks like.